Well, happy Saturday, everybody. It is November the 8th or 9th? I'm not even sure. 2020. Anyway, what I have here is another punch-out PCB. This one was a very peculiar one. I will show you what it's doing. It works great. Sound works, everything. But I'll show you. Actually, I'll just see if you can see what it's doing. I'll even cue you when you can see an issue. Coming up right here, right now, you see it? You see it? You see it? See the little flakies? The little flaky white there? You can also see a little funkiness on the punch-out screen. It's so... See that little white sparkly up by his hair? Now watch this punch-out screen. Look at the glove. See how it's just moving almost? It's so hard to see. It's a very tedious issue. I've had this board for a while. Just finding these little things is hard. It's like I like to use process of elimination to eliminate this stuff. Well, I got a punch-out board set in recently, so I did some board swapping, and it turns out my problem is on the CPU board. And what I went ahead and did off camera before I did anything was I replaced the 4 DMA counters, and you can see they have been replaced, and you can see it didn't fix the problem. I firmly believe this has something to do with DMA, because that is the thing on this board which dumps data onto the video board to be processed, basically. So what I'm going to have to do is go through that whole DMA section, and I got the schematic out right here, and I'm going to go over it. And where does stuff come from? You know, what makes this address? What is this? Where's that come from? It's address. Is that just the address bus? It could be anything connected to any part of this DMA section. So I'm going to have to go through a lot of stuff to find this funkiness. And I think I'm going to start at the very beginning. Or you know what? No, I'm not. I'm going to start at the very end. I'm going to start here where DMA is dumped onto the video board. And I'm going to start back. I'm going to start with these latches. I've already replaced these guys. I know they're good. But I'm going to start analyzing these 2 DMA latches. And then there's control signals, you know, clock signals and stuff. There's all kinds of control signals to these. There's a clock signal. There's this pin 11 to this 194. Ooh, it's a 194. That's a shifter. That could be my problem right there. It could be any of this stuff, honestly. But that little funkiness kind of looks like a shifter issue. You know, a little sparkly nonsense. It's hard to find that stuff. I'm going to start here. I'm going to analyze these guys closely with my logic analyzer. And then I'm going to move on to this guy. So that'll be my plan of attack. I'm going to analyze both the latches. I'm going to analyze the shifter. And if that all turns out good, I'm going to start looking at control signal, the clocking signals, everything like that. And just kind of work my way back. So let's fire up the analyzer and throw it on this thing. Alright guys, I am going to go over hooking up and setting up my logic analyzer. I've got it all kind of out here. This is pod number 1. I've got it grounded. I ground it through my oscilloscope probe. It grounds the whole thing if you ground that. So this is pod 1. Okay, this is pod 2. This is in the way. Okay, now move that. Alright, so pin 1 of this guy is the enable, and it is always grounded, so I do not have to hook that up because I already know it's always enabled. But the clock I do need, and that's going to be my first wire. That's going to be input 0 is pin 11. That's the clock. So let's take this, and I'll take input number 0 and put it on pin 11. Right there. Now we take input number 1. That's going to be, we are on 7A. And this does have 8 bits in, 8 bits out. So now we're going to go you know what, let's do the low side first. Let's do address 0 through 6. So this only has 7. This only has 7 bits. So we'll hook up another bit when we do the other latch. But this one we're only doing 7 in, 7 out. So we've got pin 11. Now inputs are 3, 4, 7. So this one will be 3. And this one will be 4. And the next will be 7. This one is 7. Okay. And our next wire is 8. Okay, and then the next one is number 5 is 13. 11, 12, 13. And then our next one, which is number 6, is 14. Okay. And then number 7 is right here, is 17. Okay, 17. Alright, now we hook up our data outside. And that is going to be wire number 0 is going to be bit 1, which is pin number 2. Wire number 1 is number 5, and wire number 3 no, wire number 2, 0, 1, 2 is number 6, and wire number 3 is number 9. Wire number 4 is number 12. Let's go right over top. 12. And that was wire number 4. So now we need wire number 5, which is number 15. Okay. Now we need number 6 is going to be number 16. And that's our 7 bits. So now we go ahead and bear with me, I'll set you up here. I'm going to raise this up a little bit. Kind of try to get a good angle into this. Okay. Now let's turn this guy on. Turn that light off so we can see a little bit better. It's not the greatest angle, but you know what? I'm going to try to move you right in front of it. It's going to be right in my way. There. Now let me see. Okay, we're going to go to Logic Analyzer. Okay. And here you can see we have 1, 2, 3, 4, 5, 6, 7, 8 bits hooked up here and 7 bits hooked up here. The one has that's pod 1, this is pod 2. Of the same module. The same, I'm not even going to get into explaining that. Anyway, the one side has 8 because it has also the clock. And then the one has 7 because it's just got 7 data bits, remember? It's just bits 0 through 6 coming off of this latch. So we're going to go to Format, and we're going to modify this label. We're going to clear, and we're going to name it Clock. And then we're going to make it 1 bit, right? That's the clock. It's the first bit that we have. That's just where we set it up as. Now we go to lab 2, we're going to modify that. We're going to call that data in. And that one, remember, is 7 bits. 1, 2, 3, 4, 5, 6, 7. 7 bits. Now we have, this one will be called data out. Okay, and that's on the other module, the other pod module, and we got 7 data bits. 1, 2, 3, 4, 5, 6, 7. Okay, now we're set up. We're labeled and we're set up. So now we can go to waveform, and then we have to set up our waveform. I always delete everything out, and then you select overlay, and then you just select everything. Clock, data in, data out. And we'll take one single shot. Okay. This is interesting. Yeah, see, it's working fine. See, every time this clock goes up, it sends whatever's on data to the output. So you see, this clock is like a train. It's just the same thing over and over. So whatever's here will be down here. So you have 3 here, it sends it. 3 here, it sends it. I'm going to disable the touch. It sends this 3 down to there, and then it comes up again, it's got 4, it sends that. It takes another snapshot here, 5, sends a 5 down. 6, see that? See that? 60, 61, 62. It's just a count. 5F, 5E. See how that's doing that? 4, 5, 6. It's a count. And then it resets to 0 every so often. Four, 5, 6, 7, 59, 5A, 5B, 5C, 5D, 2, 3, 4, 5, 6, 6, 7, and then it reset to 0. 1, 2. See that? 31, 32, 33, 34, 35, 36. So that's how that works. So you got to 7, then it reset to 0. Every now and again it'll set a reset pulse for, you know, it's just how it's designed. Reset pulse, 1, 2, 3, 4, 5, 6, 7, reset pulse. That's those counters, those 61s are being reset. They're being reloaded. And they're predestined. They are preloaded. All of the inputs on those 61s are grounded. So when it loads, it automatically loads 0. Boom. 1, 2, 3, 4, 5, you know. So that's working just fine. So I'm going to go ahead and hit the other one, and I suspect the other one will be okay. But I'm going to go ahead and, because if something was wrong, it would be catastrophic. There would be something really wrong with that. What I got going on is something's flaky, you know. I don't see no flakiness here. Yeah. All right. I'll be back. I'm going to check the other one out and be back. Okay, I have found something that is definitely a little bit flaky. Here is this other latch that I'm on. I was doing the other one. And this one has 8 bits. This is this guy right here. 7A. And this one has 8 bits. Remember, the other one only had 7. This one has 8. So I've got that wired up. And right here you can clearly see 7D on the input, 7F on the output, and then it goes to 80. I'm triggering on 8. I'm triggering on the this going high. This goes high and it goes over and it does stuff. I don't know. But I wanted to trigger on the most significant bit going high. And that's when I found this. And it always does that. I can repetitive run it. That is definitely flaky. See, it's 7F and then it goes to 0. Fine. But over here it is clearly 7F. So I think I am going to replace that latch. And then we will see what's going on. Because that's definitely enough flakiness right there to cause my problem. Because it's not flat out bad, because it goes back to 0. You remember 7F is 1111. That F part of 7F is 1111. And then the next latch, it goes to 0. 0, 0, 0, 0. So it's not stuck high. It's just not working right. This is one of them problems that without an analyzer and stuff, it would be so hard to find this stuff. Because it's not a flat out bad part. But I'm going to go ahead and replace that 374, and we'll see what happens. See if we can get rid of little twinkles up here. It doesn't do it right here. It's only when he's up in the corner. It's only when he's up in the corner over here. You see that? You see that little twinkle. Well, you can kind of see it every now and again. Just white twinkly. We're going to have to wait. We'll have to wait. Come on, knock him down. That's the DMA addressing, remember? Alright, now here comes the punch out. Now look at the punch out logo over here. No, wow, it's won't. Ugh. This thing won't focus. We'll try to catch old Glass Joe's twinkle. He's got a twinkle in his hair. It's very hard to catch with the camera. See it? I saw it. It's hard to catch. Anyway, I'm going to go ahead and replace that 374 and see if we can take care of this flakiness. Alright, I'll be back. Guys, I think I figured it out. I replaced this guy right here, and lo and behold, I hate it when you find something that looks flat out wrong. You fix it, and it doesn't. You replace it, and it doesn't fix the problem. I hate that. But I did replace that. That was not my problem. I'm sorry, I'm way out of frame. I replaced that, and it wasn't the problem. It was still doing the little, you know, Glass Joe's dandruff was still showing up. So I got to looking at the board, and I came upon this chip right here. Come on, focus. Let me set it down. It's a 74 ALS04 with a capacitor across. Okay. It went right here. I just didn't like that guy being an ALS74 with a capacitor across it, so I put in a nice National Instruments national semiconductor, I should say. 74 LS04. Just simply because I didn't like that it was an ALS, and the schematic calls for an LS04. And that's it. That was the problem. There's no more dandruff. Glass Joe don't have any more dandruff. It's been on, like I said, it's been on for about 15 minutes. And usually that little flaky shows up after about 2 minutes. If that. So I'm going to let this thing go. I'm going to let it play and play and play. And we'll wait one more cycle here. The punch-out logo, the pink part of the glove, right there, would always like move or something. Now it's not. It's solid. It's as solid as I could hold that. But it used to have, like, in the corner of that little pink glove, it would, like, you could see like sparklies in it. And now you can't. So now we'll look at Joe's hair. See? Nothing. No dandruff. So we're going to call it good. I'm going to let it run though. I'm going to let this thing go for another 3 hours. Just sit here like this. But barring any more dandruff showing up, we're going to call this one good to go. Guys, I want to show you something. Follow me. Hey guys, you're on camera.
No.
Neighbor kids. Okay. I gotta come in and get something. First of all, check this out. Michigan cherry barbecue sauce is the bomb. This is apple cider vinegar and apple juice. There's my little buoy, little boo-boo. Say hi. No, she's tired. She's hanging out by the grill. Time to spritz. And I also need to rotate them. So I'm going to put the camera down and rotate them. Thanks a lot, guys. We'll see you on the next repair.